Hello, can you hear me loud and clear?
Yes, sir, we can hear you.
Yes, sir. Yes, sir. Good evening, sir.
All right. Good evening, class. We'll continue from where we stopped the last time. We were discussing or treating change surveying the last time. By the grace of God, we should be able to conclude that this evening. And by the next class, we should be looking at a new topic entirely. Um, I'll be using two materials this time around because I convinced that these two materials will be enough for the class to have full comprehension of the topic, which is change surveying. So I will be interchanging using those two materials. So let me quickly share one of it. Sorry. Just give me some seconds. I'm trying to, okay, I've seen it. Hello, can you hear me?
Yes, sir, we can hear you.
So just give me some few seconds. Seems my system is having an issue here. What can you see on the screen? What can you see? Tell me.
It's just loading, sir.
No, we
Nothing.
can't see anything yet.
Okay. I've shared the document I want to share, but it's not responding. I don't know why. Okay, can you see my screen? Can you all see my screen?
No, sir, it's still loading.
Ah, well, it has responded from
We
my
can see
Okay,
it
end.
now,
sir,
sir.
it's showing.
You can see it now.
Yes, sir.
All right. Let me see if there's no other issues. All right. So change surveying or change survey, we said in the last class that in change surveying, we deal with linear measurements, that is distance measurements, and don't forget when we treated linear measurements as a topic, we said it is the one of the basic operations in geomatics, taking linear measurements. So in change surveying, all what we do is to take linear measurements. And I also told you last time that change surveying, the fundamental principle of change surveying or change survey is triangulation. And that triangulation means creating series of triangle to map a geographical area. Okay, so we deploy the use of triangles, series of triangles. And these triangles are, they must be well-conditioned triangles. You know, they must follow some specific conditions. We don't just draw triangles anyhow within the said geographical area or location uh, in deploying your chain surveying. Now, chain surveying, as you can see on the screen, is also a simplest method of surveying. Okay, in chain survey, only measurements are taken in the field, and the rest work, such as plotting, calculation, etc., are done in the office. So measurements are only done in the field or the site location. Other work will be done in the office. So only linear measurements are required, as I've said earlier on. No angular measurements. More suitable, adaptable to small plain areas with very few details. So where you can deploy chain survey is when the site location or the field in question is a small area, a small plain area with very few details. We don't have too many details. Details that are within the said location are few. Okay. So if a chain survey is carefully done, it gives quite accurate results. So when can we use chain survey? When can we use chain survey? Okay. One of the field we can use chain survey is an area that is a small area. So for comparatively small areas, when the areas to be surveyed are comparatively small, chain survey or chain surveying can be deployed. Now, another one is when the location or the area is fairly level ground, that is, it is relatively flat. There are no undulations, the location is relatively flat or fairly level ground. You can deploy chain survey or chain surveying. For open areas and for simple detailing and less information, as I've said, that where we carry out chain survey, we must have little details, few details. Okay, so these are some of the conditions that must be met for you to deploy chain surveying in mapping a geographical area or location. So if any of these points is missing, then you cannot deploy. Take, for instance, if I take one out, the first one, and the other three conditions are met, but the area is large, I won't be able to deploy chain surveying to map the area. So I will have to use another type of survey. So I think we have a few of the conditions that must be met here. Let me quickly confirm if we have more. Okay, I think this is more. Can you see my screen?
Yes, sir.
What do you see?
Some principles of chain surveying.
Okay, good. So I've told you I'll be interchanging because I want to pick details from the two notes because there are some certain things that are here that you won't find in the other one. So combining the two together, we can have a detailed lecture this evening. So, but let me come, this is not what led me to this slide. I was looking at the conditions that must be met. And in that other slide, we have a few conditions listed. So look at it now, suitability of chain surveying, that is, conditions that must be met for us to deploy chain surveying. So chain surveying is recommended when ground surface is more or less level. I've said that in the previous slide I shared. Area is small. When the area is small, when we have small scale map is required to prepare, chain survey can be deployed. Formation of a well-conditioned triangle is easy. So I've mentioned that earlier on, that the principle of chain survey or chain surveying is what? Triangulation. And what do we mean by triangulation? Creation of series of triangle within the said area, to map the location or to map the area of concern. Now, I've said that these triangles, you don't just draw them anyhow for the purpose of carrying out chain survey to map the area. Those triangles must follow certain conditions. Okay, so that is what we mean by formation of a well-conditioned triangle. Okay, so it's easy. So what they are trying to say here is that in creation of the triangles, the area must be suitable such that I can easily draw those condition triangle on that area. So I can easily form those condition triangles. So an area that is difficult to create those condition triangle, we cannot deploy chain surveying in such an area. So chain surveying is not recommended when the area is crowded with many details. When we have many details, you can't use chain survey in that area. Area consists of too many undulations. That is, we don't have a flat, the place is not relatively flat. We have many undulations. You can't deploy chain survey. Area is very large. Formation of a well-conditioned triangle is not easy. So it's just the opposites of the recommendation given. All right, so let's take notes of that. So I'm still coming to this to explain what the well-conditioned triangle simply means. Talked about this, the principle of chain surveying, which is triangulation, and is divided into a principle. The principle of chain surveying is to divide the area into number of triangles. Okay, and that process is triangulation. So that's why we simply say the principle of chain survey is what? Triangulation. As a triangle is the only simple plane geometrical figure which can be plotted from the lengths of the three sides, even if the angles are not known. A network of triangle is preferred to chain surveying. Triangulation is the principle of chain surveying. If the area to be covered is to be surveyed is triangle in shape, and if the lengths and sequence of its three sides are recorded, the plan of the area can be easily drawn. So this is a concept we deploy when doing chain surveying. We introduce a well-conditioned triangle in carrying out the survey of that geographical area. And with triangle, you can easily take the linear measurement, the distances of the three sides. And if I have the length of the three sides of triangle, I can easily compute the area of the triangle. All right. So having known the area of those triangles, I can easily also determine the total area of the landed property that is the concern. So we are concerned about. So look at it now. So look at this property. We have A, B, C, D, E, F, G, H. All right. So these are the points that defines the boundary of this property. A, B, C, D, E, F, G, H. So these are the points that define the boundary of this property. Now, within this property now, we now create triangles were created. So we have 1, 2, 3, 4, 5, 6, 7, 8. About 8 triangles. Can you see how then the length of the sides of the triangle are measured? So with this, I can determine the area of these plots of this property. Okay, by adding the area of each triangle together. So this principle of change surveying. Now look at another typical example here. You know, the boundary, we have boundary A, B, C, D, E. Okay, so that's a boundary. We have a road here that is just in front of the property, where we can use to assess the property. Then we have series of triangles created now. Look at this. Now, how many triangles do we have here? 1, 2, 3, 4, 5, 6. 6 triangles. Okay. So can you see some details here? We have the tree, we have the pond, we have the house. Okay, we have the road. I don't know what was written here. We have the dish here. So these are some of the few details which are even outside the boundary of the property. They are not within. There are some that will be within. Okay, so this is a typical example. So look at this now. This is another example. The boundary of the property has been divided into a series of triangles. So we've looked at this before, where change survey can be deployed, and where it cannot be deployed. Okay, so what is well-conditioned triangle and ill-conditioned triangle? An angle is said to be well-conditioned triangle when no angle in it is neither less than 30 or greater than 120. So triangle is a triangle whose angle is not less than 30 degrees and whose angle is not greater than 120 degrees. So such triangle is a well-conditioned triangle. I hope you are following and you are taking notes of all the make a triangle. An angle is less than 30 degrees or greater than 120 degrees. It is called a conditioned triangle. So that is any triangle that violates the root of a well-conditioned triangle is called an ill-conditioned triangle. All right, an ill-conditioned triangle is angle that is less than 30 degrees and that is also greater than 120 degree. So that's an ill-conditioned triangle. Now, an equilateral triangle having angle of 60 degrees is an ideal triangle. So in your O-level mathematics, equilateral triangle, it means that triangle has equal sides and equal angles. Okay, triangle. So I've talked about a well-conditioned triangle. I've also talked about ill-conditioned triangle and an ideal triangle. So take notes of that. Next slide. So time related to change surveying. I think we have a few of these times in the last class. Now, okay, I think it's better I switch back to the other slide. I think that one will give a better definition. Some terminologies now. Main stations are the ends of the lines which command the boundaries of the survey and the lines joining the main stations. We are called the main survey line or the chain lines. So let me quickly show you what that definition is saying in terms of diagram or illustration. Well, I don't think it's here, or maybe I can't find. I know this. Okay, good. Now, this is what that definition is saying for main station. The main stations now, look at it very well. These are the main station. This A, B, H, C, D, E. These are the main stations because these are the stations that define the property, the area. Okay. They define the area. So now the line connecting these stations are called the main survey line. They are called the main survey line because these stations are called main stations. So any line that connect them together is called main survey line. I hope you are following. So let's go back to now we have subsidiary or the tie station are the points selected on the main survey lines where it is necessary to locate interior detail, such as fences, edges, buildings. So let me go back to the diagram. Now, the main survey line, any points on the main survey line are called the subsidiary station or sometimes tie stations. All right. But this diagram now, because this symbols is a symbol of main station, they are also saying this is a main station, this is a main station, which I find it quite because what they are saying here now from E to F now, this station E and F is also a main station. Okay, which is not the case. The main station are the station that defines the boundary. So look at it now, which command the boundaries of the survey line, and the lines joining the main station are called the main station or the chain line. So we have issue with this diagram. Okay, let me go find a better diagram. I hope I think we can't find a label diagram. But anyway, let me use this. Look at this. A station A, B, C, D, and E are the main stations. So the line connecting these main stations are called the main survey lines. Or sometimes they call them the chain lines because these are the lines that define the property, the area. All right. So we need this diagram. So now when we now have let's assume that I create a point now between line A to E now. I create a point. That point is referred to as a subsidiary station or a tie line. And what do we use that station for? Is to locate details or features within the said property. The features may be building or fences or pond or trees. So that is what we use the subsidiary station or tie station for, to locate the interior details within the said property. All right. So, all right. So I'm coming. We have lines now. We have the baseline. I think I've talked about this baseline last class. That is the longest line in any chain survey. The longest line is taken as the baseline. It is the main and longest line, which passes approximately through the center of the field. Detailing work carry out with respect of this line. So it always passes through the entire area of the field we are want to map or survey. So that is baseline. Then check line or proof line. That's another name. Instead of calling it check line, we call it proof line. Is a line joining the apex of a triangle to some fixed points on any two sides of a triangle to check the accuracy of the framework. So the check line, its major use is to check the accuracy of the framework. Okay. The length of a check line, as mentioned on the ground, should agree with its length on the plan. So a check line, the length of a check line on the plan must tally with what it is on the ground. So let's go back to that illustration diagram again. So look at it now. They call this line now a check line. Okay, because it's coming from the apex of a triangle to a fixed point within the said property. If you look at the definition, a line joining the apex of a triangle to some fixed points on any two sides of a triangle. Okay, on any two sides of a triangle. So look at it now, this line now, joining these fixed points here on any two sides of a triangle. So this is a triangle, one of the side of a triangle. This is another side of a triangle. So this is a check line. This is also a check line. Okay. So this line now is not a check line because it's not on any side of a triangle. I hope you are following my details, my explanation. So this line now, from here, G to B, is it a check line? Line G to B. Let's respond now. Is it a check line?
No, sir.
Why is it not a check line?
Because it's not joining the apex two sides, sir.
Yes. Don't forget the check line is from the apex. It's from the apex. This is an apex of a triangle. B to G. So it's not joining any of the two sides. So unlike this one now, from here to here is joining any of the two sides of a triangle. I hope you are following. Then look at this now. line H to G from the diagram here is a check line. Okay, because it's joining any of the side. It share this side and this side with this triangle GHC. All right. Now, I think we have defined a tie line, and all of these lines are derived from their stations or points. When we are talking about tie lines, you should know that tie line is from what? Their tie station, from tie station or tie points. Because joining two tie stations together, we will have what? A tie line. All right. So take notes of that. Now, look at that. This is a tie line. What makes this a tie line? A point on a survey line or main survey line joining a point, another point within the said property. So this is a tie line. This is a tie line. And this is a tie line. So what do we use tie line for? We use it to locate interior details in the survey area. So any details that are within this property now, within this area now, if we have building, if we have trees, if we have electric posts, we use interior tie line to locate them. Okay. But what do we use check line for? For accuracy of the framework of the change survey. So that's what we use the check line for. I hope you are taking notes of all this now. So let me go back to this. So can you see what this this slide is talking about? All the stations we have looked at, the main stations, the subsidiary stations, the tie station, it's categorized all of these stations under one station as they are survey stations, and that is correct. All of these stations are survey stations. So type of survey stations, we now have the main stations, the subsidiary station, and the tie stations. Now, look at main stations along the boundary of an area as controlling points are known as main what? Stations. So that's why I was telling you that this diagram I show you is not a perfect one. The main stations, main survey stations here are stations A, B, H, C, D, and E. Stations F and G, they are not main station. So this symbol should not be used for them as if they are main station, because the main survey station define the property, the boundary of the area to be surveyed. So I hope that is clear. And that is what was emphasized here. The line joining the main station are called the main survey lines. Okay, the main survey line should cover the whole area to be surveyed. The main stations are denoted by this symbol. All right. So subsidiary stations. Stations which are on the main survey line or any other survey lines are known as subsidiary stations. These stations are taken to run subsidiary lines for dividing the area triangles, for checking the accuracy of triangles, and for locating interior details. Now, these definitions are captured your tie tie lines and it has captured your check lines. Okay, it has also captured your tie station if you are following. Okay, the subsidiary station. Station that are on the main survey line or any other survey lines. Okay, and what do we use them for? We use those lines to create series of triangle, then for checking accuracy of triangles. So for checking the accuracy of triangles, what type of line is that? What type of line is that for checking the accuracy of the triangles or the chain survey framework? What type of line is that?
The check line, sir.
Let's respond now. Eh?
The check
You
line,
said
sir.
what? Yeah, check line. And for locating interior details, what type of line is that?
The
For
tie
locating
line.
interior details.
The tie
Tie
line.
lines. Good. Good. So take notes of that. Now, tie stations, you know, these stations are also subsidiary stations taken on the main survey lines. Lines joining the station are known as tie lines. Tie lines are taken to locate interior details. So let me break it further down. Now, when we have a subsidiary station can be a tie station. So take note of that. That is what this definition is saying. Okay, so line joining two tie stations is called tie line. A line that joins two tie stations is called tie lines. Tie line. And tie line is used to locate interior detail within the said property. All right. So let's take note of that. So we will have many tie lines. That's why, you know, this slide is talking in polars. We have many tie stations. So for that fact, we'll have many tie lines. Okay, and we use these tie lines to locate interior details within the area to be surveyed. So main survey lines, the line joining the main station are called main survey lines or chain lines. As you can see, can you see the triangle symbol for the main survey lines? Okay, these are the main stations, the main stations or main survey stations, you know. So the line joining them is the main survey lines or chain lines. Now I've talked about the longest line in the chain survey, and it all passes through the property or the area of the survey. The line on which the framework of the survey is built is known as baseline. That's another definition. Take note. The line on which the framework of the survey is built is known as baseline. So that means if baseline is not available, then chain survey cannot be done. Okay, because the accuracy of your chain survey will depend on how accurate your baseline is. So if the baseline is not accurate, then the whole activities for chain survey will be wrong. Okay, it is the most important line of the survey. Take notes. Generally, the longest of the main survey line is considered as the baseline, the longest of the main survey lines. So this special main survey lines now, it always passes through the area, you know. It's not a line that is part of the it's not part of the survey lines that define the property. Okay, I hope I will see an illustration of this in this slide so that I can explain better. This line should be taken through fairly level ground. So when you are determining this baseline, it must pass through a fairly level ground. Don't forget, part of the condition for you to deploy chain surveying that the area should be what? Relatively flat or comparatively a flat ground. So when you are determining your baseline, the 2 points that connect your baseline, as you move from that point to the other points, that part must be fairly level ground and should be measured very carefully and accurately, because if it's not done so, then all your chain surveys will be totally wrong. There will be error in every other measurement you carry out because your baseline is not accurately measured. All right, so take notes of that. Tie line, I've explained this. Okay. So another thing that I didn't mention about it can also serve as a check line. The tie line can serve as check line, but know that what tie line is used for is to locate what? The interior details. Okay, to locate the interior. That is major responsibility. Okay, you can use it to it can be used to as check line, but tie line is used to locate interior details within the said property. And for accuracy of the chain survey framework, know that it is the check line that is responsible for that. Selection of survey station. The following should be considered while selecting survey stations. So when you want to select survey stations, what are the things to consider? The station should be visible from at least 2 or more stations. So survey station should be intervisible. Okay, at least 2 or more stations. You should be able, when you are standing at one of the stations, you should at least see 2 or more stations from where you are, from the station you are standing. As far as possible, main line should run on a level ground. Okay, main lines should run on level ground. All triangles should be well conditioned. I will explain that, the meaning of well conditioned. That is, no angle is less than 30 degrees and no angle is more than 120 degrees. Main network should have as few lines as possible. The main network should have as few lines as possible. Now, I think I've explained all the terminologies we use in chain survey. And I think I've mentioned the instruments that let me switch this. I want to confirm if I've mentioned. Okay, I think while we are doing linear measurements, I think I made mention of. Now, this instruments you are using is part of the instrument we use for chain survey. All right, because as I said at the beginning of this class, that chain surveying, what we do is what? Linear measurements. We do distance measurements, So look at it now. I've discussed this type of chain, maybe 2 weeks ago, and I said that you should know the characteristics or properties of these chains. This one has summarized it for you, in a better way. Can you see the metric chain, the Gunter chain, or surveyor chain, the engineer chain, revenue chain, and their properties highlighted for you. So the measuring tapes, the types that we have based on the material that is used to manufacture it. There's something I'm looking for. So I've explained wedging for you. This is another slide talking about direct ranging and reciprocal ranging. Okay, I think I can't find it. There's a slide that lists the equipment or instrument use in chain surveying. You know that we use chain or tape. I think I listed in those instruments for you 2 weeks ago. We have the chain or tape. Okay, we have the pegs, we have the arrow, we have the ranging pole. So I listed them like that. So please take notes of those instruments. Okay, so let's quickly move to this operation in chain surveying. We have operation in chain surveying. What are the operations? Okay, the following operations are involved in chain surveying. We have the chaining, we have the ranging, and we have the offsetting. What you don't know about this operation is the last one, offsetting. I've explained chaining, I've explained ranging. So for the avoidance to clear doubt and to know if you are actually following my lecture as you ought to follow. So I'm going to throw that question out. Can somebody help us the meaning of chaining and the meaning of ranging? Then we'll now go to focus on offsetting. Now, chaining, who can help us? The meaning of chaining. Hello? Can you hear me, or I've been talking to...
You can hear.
Respond to me now if you can hear me. Respond to my question. Someone should explain chaining and someone should explain ranging. I've taught that, I think, the second class, the second lecture of this class. Oh yeah, who want to help us?
So, Chini, so can you
Yeah, go ahead, I can hear you.
tuning is measuring horizontal distance, while ranging has to do with alignment of points.
Okay, I'm not satisfied with your definition. Who else can help us? Chaining.
There is a
Okay, go ahead.
that chaining is the measurement of distance using chain.
Yes.
While ranging
Chaining is
is
the measurement of distance.
using chains or tape. A chain or a tape.
Ranging is what?
Now, while ranging is the process whereby the intermediate points of the distance is while ranging is the positioning of the intermediate points between the lines.
While ranging is position of intermediate points. That's all what I
Between the
could
lines.
hear you say. Is that all what you said about ranging?
I
Position
said
of
while
intermediate
ranging
points.
is the positioning of intermediate points between the lines, like the two end points of the lines.
Okay. Who else want to help us? You've tried?
Can I try, sir?
Okay, go ahead.
Okay. Chaining is measuring the distance using the
I can barely hear your voice. Can you increase the volume of your voice?
yes, sir. Can you hear me, sir? Can you hear me,
Yes,
sir?
speak louder, speak loud.
Okay, I see. Chaining is measuring the distance using contact sheet or measuring
Using
contact sheet.
using what? Wait,
Contact
chaining is the measurement of distance using
contact sheet.
I did not using compass. I think did you say compass?
I say contact chain, contact chain.
Gunter's chain. Okay,
Yes,
Gunter's
sir.
chain. Okay.
or measuring tape. Then for the
Or
ranging,
measuring tape. Okay, good.
then
Good,
from the ranging,
fantastic. Then ranging.
it is measuring the position of points along a
Can you
line.
speak louder? I can't hear you again.
Then for the ranging, sir, it is
Yes.
measuring of the position of points along a line.
Positioning of
Points, sir, points
of
along a
points.
survey line. Yes, sir, along the survey line.
Okay, good, good. So I give it to you. This last person, I'll give you 10 over 10 if I'm to score you. Okay, I'm satisfied. So we say chaining is measurement of distance using chain or tape. Using chain or tape. So that is chaining. Okay. The first two speakers just said measurement of distance. You did not tell us what instrument do we use. Okay. So we use chain or tape for measurements of distances or taking linear measurements using chain or tape. So that process is called chaining. Then ranging, the process of establishing intermediate points along your line of measurements while taking your distance or linear measurements. And I've told you the reason for doing that. Okay, why you range. Okay. And, that led us to discuss the direct ranging and reciprocal or indirect ranging. Okay. So now offsetting. Offsetting in chain surveying is done when we want to locate interior details. I told you some minutes ago that tan lines are used to locate interior details within the property or area to be surveyed. All right. Now, we do that by using this offsetting operation. So offsetting is the procedure that we deploy, to use timelines in locating interior details within the property. Okay, so these three operations are done simultaneously during chain surveying. So when you are doing chain surveying, you are doing these three operations simultaneously. As you are chaining, you are arranging, you are also offsetting. So take note of that. I need an illustration that depicts offsetting for us. I'm coming. Although there are different types of offsetting, but I just want to show you what we are talking about offsetting. Okay, can you see? Look at this now. These are a typical example. This is a chain main survey line now, A and B. So look at this now. Along the line now, this is a perpendicular offsetting, and this is a tree. So for me to have this line here, which means there must be a point here. So the point here now will be a subsidiary station or a tie station. So then this line now, a perpendicular offset is used to locate this tree. So this is perpendicular offsets. So as you can see also here, perpendicular offset to locate this pole. So look at this now. When the line is slight, it's not perpendicular will mean that this main survey line is at right angles to this line. But when it is slightly bent, it is not perpendicular again. So it is called oblique offsets. Okay. So take note of that. So let's go back. So we have the definition of offset now. Lateral measurement to chain lines for locating ground features or are known as offsets. So your lateral measurements to chain lines for locating ground features are known as offsets. And I've shown you in that diagram. So for this purpose, we have the perpendicular or oblique offsets may be taken. If the object will be located, say road is curved, more number of offsets should be taken. For measuring offset, tapes are commonly used. For measurement of offset, we use tape. So offset, which can be judged by naked eye, or offset less than 50 meters is called short offsets. An offset greater than 50 meters is called long offsets. Most commonly, short offsets are preferred. So take notes of that. Offset may also be classified as perpendicular offset and oblique offsets. I've explained what is perpendicular offset and the oblique offset for you. So, okay, let me just whet our appetites here more on perpendicular and oblique offsets. The offsets which are taken perpendicular to the chain line are termed as perpendicular offsets. Okay, I've explained that in this diagram. This chain line is perpendicular to this line, and this is the offset line. So which means this line, this offsetting is called perpendicular offset because it is perpendicular to the main survey line AB. So, but these offsets are taken by holding zero end of the tape at the object and swinging the tape on the chain line. The shorter distance measured from objects to the chain line is usually the perpendicular offset by setting right angles in ratio 3:4:5. Can you see? Then by cont'd or optical square. So this ABC you are doing, you are seeing on the slide, is telling you ways you can achieve perpendicular offsets. One, by holding zero end of the tape at the objects and swinging the tape on the chain line. Okay, so let me go back. So zero line of the tape here at the object, then swinging it to here, you can take the offsets. That's what that first one is saying. By holding zero end of the tape at the object and swinging the tape on the chain line, the short distance measured from object to the chain line is usually the perpendicular offset. One way of doing perpendicular offset. Another way is that by setting right angle in ratio 3:4:5, 3:4:5. Then C, by using cont'd or optical square, you can achieve your perpendicular offsets. Okay, perpendicular offset is usually preferred than the oblique. I've told you when it is oblique offset, that is the line is not, the two lines are not perpendicular to each other. Okay. So look at illustration here on the types of offset we have. This is a perpendicular offset now. Can you see? It is perpendicular to this line. Perpendicular offset. Can you see the feature we are taking? This is a building, and this is the chain line or the main survey line. Perpendicular, can you see perpendicular offsets? As you can see. So that's a typical example of perpendicular offset. Then the oblique offset, oblique distance is always greater than perpendicular distance. tilted. So a tilted line will always be longer than a straight line that is perpendicular other. Two lines that are perpendicular to each other, that line that is perpendicular to the main line will actually be shorter than the one that is bent. All the offsets which are not taken at the right angle to chain line are known as oblique offsets. So can you see the same diagram I showed earlier on now is not depicting oblique offset. Can you see this line is tilted? It's not a straight line as the one we have before. So it's tilted. This also tilted. So these are the oblique offsets. Okay. And it's always from the fissures to the what? The chain line or the main survey line. So can you see this line? What I call this line for you earlier on, that is, they are tie lines. Can you see? They are tie lines. Well, is an oblique offsetting that is used to locate the interior detail, which is the building. Okay, so oblique offset. This is the main survey line or the chain line. So we've looked at the perpendicular offsets and the oblique offsets, and their literal measurements we take to locate the interior details or fissures within the area that is being surveyed. All right, this is another example of perpendicular distance and perpendicular offsets and the oblique offsets. Okay, can you see this line? These two lines are perpendicular. These are oblique lines. So oblique offsets. Now, perpendicular offsets by stringing. You know, I've told you how you can achieve perpendicular offsets by stringing the tape. You take the zero end of the tape from the objects, then you string it to the chain line or the main survey line. Another way is you create a right angle triangle of ratio 3, 4, 5. Another method is when you use your quarterstaff, or what's it called? Let me go back to quarterstaff or optical square. Quarterstaff or optical square. So that is that. So this is explaining the stringing method, the perpendicular offset by stringing. Can you see? This is the object that is concerned that we want to locate the interior, the location. We want to locate the interior the fissure here, is interior, is inside this property. So these lines you are seeing now, they are tie lines. Now, as a result of these three lines, which means we have 3 tie stations here, which are 1, 2, 3. Now, one of the lines use perpendicular offsetting to locate the interior detail here. The other two use the oblique form of offsetting to locate the interior details. Don't forget, this is the chain line or the main survey line. So this is an example of perpendicular offsets by stringing. So this is also giving us more details on that. perpendicular offset using cont'd or optical square. That's another method. So this one is the cont'd, and this the type of cont'ds we have A, B, C. So anyone can be used. Perpendicular offset using cont'd. So this is the instrument. So perpendicular distance using optical square and prism square. So this is the illustration on that. So look at it now. This is a typical scenario when a surveyor is on the field carrying out chain surveying. Okay. So this is the method of the 3-4-5 method for perpendicular offsetting. Now we have procedure for field work for chain survey. Procedure for field work, we do what we call recognizance survey. I've told you what we call recognizance. Recognizance is when you another name for recognizance is preliminary survey. So before the main survey, you visit the sites or the field to be surveyed. You study the environment, you determine how best to carry out this chain survey. Okay. In visiting the site in your recognizance survey, that will even inform you what type of survey to deploy. If you intend to use chain survey before and you now visit the sites doing your recognizance survey, and you now discover that this place is not comparatively or relatively flat, and it did not or it does not meet other conditions where we can deploy chain survey. So from that information, you won't be able to use chain survey. So recognizance helps you in your preparation in carrying out the survey work. So it makes you to familiarize yourself with the environment. What are the do's and don'ts? Environmental hazard, how the best approach, in carrying out whatever survey you determine to carry out in that environment. Okay, so recognizance is the preliminary survey, preparation for the main survey work. Now we have the index sketch. Okay, can you see now what I've said? The preliminary inspection of the area to be surveyed is called recognizance. The surveyor inspect the area to be surveyed, survey or prepares index sketch or key plan, walk the whole area and thoroughly examine the ground, know the position of boundaries, road, rivers, etc., various difficulties to chain lines, select stations, and prepare any sketches called index sketches or key plan. So during the recognizance survey, the surveyor will produce index sketches or key plan, in his planning for the main work. So we have the index sketch. Let's go to okay, we have discussed the index sketch. Is the sketch that the surveying will draw while doing his recognizance. Okay, the surveyor will prepare the index sketch or the key plan. So marking the stations on ground, we've said also that surveyors will mark stations are marked with wedging rod or wooden peg, driven a nail or sparks if hard surface, or embedding stone with a cross mark. So we use the wedging rod or wooden pegs to mark stations on the ground. Then we have the reference sketches. After marking, the station should be referenced, that is located by measurements called ties taken from three permanent points, which are easily identified, such as corner of building. So that is what we refer to as, and in the final required measurement are taken and located on the field book. So that's what we refer to as the reference sketch. After you mark the stations on the ground, they should be referenced. And how do we reference them? You carry out measurements, called ties, taken from three permanent points, which are easily identified, such as corner of buildings. So, I think we are done now. So, procedure of field work recognizes the index sketch, marking the stations on ground, reference sketches, taking measurement of survey lines, and noting them. So these are the procedure for field work for Shane survey. Do you have any questions you want to ask me? Any question from what I've explained on Shane survey or Shane survey? No questions. So all that I have said is well understood.
Excuse me, sir.
Yes.
Yes, I have a question, sir.
Yes.
Yes, sir. When you were talking about the checkline, sir, you mentioned something about it being on level ground. I didn't really get that part, sir. Please, can you re-explain, sir? Thank you, sir.
I didn't get you.
Sir, I said
when I mentioned what?
The checklines, sir.
Okay, the checklines.
Yes.
Okay.
You said that they are meant to be on level ground or something. I didn't really get that part, sir. Please help us re-explain, sir. Thank you, sir.
Oh, I didn't say a check line must be on the level line. Anyway, I've told you that one of the conditions to be met for us to deploy chain survey or chain surveying is when the area is small. Okay. Another one is when we have a relatively flat surface. Okay. So what I said about when we are creating a line, we must make sure that the ground is level or relatively level, is when I was referring to the baseline, not the check line, the baseline. And I've told you the baseline is the most important line in the chain survey framework. Okay, it's the longest line, it's the most important line. If that line is not accurately mentioned, all other measurements will be wrong. Okay, so everything depend on the baseline. So as you create the baseline, the space it passes. Okay, the direction of the baseline, the ground surface must be relatively flat. That's what I was saying. That don't forget, I told you that the baseline will pass. The baseline passes across the property. It passes most of the time. It passes across the properties. So let me show you a diagram. If I can get a typical diagram that explains baseline. I hope I found it. Okay, so let me use this. Who can tell me what is where is the baseline here? This diagram we are seeing. Who can tell me the baseline?
The one from A to C, sir.
Yes, good. The one from A to C is the baseline, is the longest line. And you can you see that it passes across the boundary? Sorry, it passes across within the area. It's within. So this line is coming from A to C. So as this line is coming from A to C, this direction this area you as it passes through must be relatively flat. We must not have issues of one point is high, the other one is low, one point is low, the other that it must be absolutely flat, a flat surface here. So that is baseline. But don't forget that the whole area is a small area, and the whole area is also what? Relatively flat. Are you getting me? But some areas will be more flatter than the other. Are you getting me? That's why when you are considering your baseline, it must pass through a very smooth surface, a flat ground. I hope that is clear now.
Yes, sir. Thank you, sir.
All right. So
Hello, good evening, sir.
Yeah, good evening. You have a question? Go ahead. Hello. I also want to ask question now.
Yes, I have a question. Yeah, it's about baseline. It's just a simple one. So I said that baseline is wrong. Hello, sir. Can you hear me?
Yeah, I can hear you. Baseline is. Hello.
Yes, sir. I want to ask you a question. Can you hear me?
Go ahead. I can hear you.
Is baseline in between, sir?
Hello. I can't hear you anymore. It's like your network is having issue.
Yes, sir.
Hello.
Is having issue.
I can't hear you clearly. Maybe you should type your question as a message to me. I can't hear you. I know you mentioned baseline, when you wanted
So
to
my
say
question
something.
is, you said the baseline is the longest line in a chain. So, sir, can you not hear me properly, sir?
Okay, I can hear you now. Can you repeat your question?
Can you
Hello.
hear me now,
Your
sir?
network has started again fluctuating.
Hello, sir. Can you
Just
hear me
type your
now?
question. Type your
I
question.
should type my question.
Yes. Someone is asking me, yes, sir, please, difference between tile lines and oblique offsets. I don't know why you are asking me this question. I've told you that when you have tile lines, it's for the purpose of locating interior details. And in locating the interior details, you either use perpendicular offsets or oblique offsets. So you have tile line. Your tile lines is used to locate interior details within the property or within the area to be surveyed. So in doing that, you carry out perpendicular offsets or oblique offsets. So have I differentiate between tile lines and oblique offset now? Oblique offset is just a procedure, or let me just use offset. Don't let me separate it. Either when I say offset, you can either use perpendicular or oblique offset. So offset is when you are taking lateral measurements to locate interior details within the area to be surveyed. All right. And while doing that, you need your tie lines. You need tie lines to achieve that. I hope that is clear. Because in using my tie lines to locate the integral details like building, trees, electric pole, etc., I can use the oblique offsetting or perpendicular offsetting to do that. Okay. Then another question says, sir, when you were talking about suitability of change survey, you said for comparatively small areas. Comparatively. What word should I use now? Kilometer. When you say kilometer square, you're already talking about area. Okay. But we're dealing with distance measurements here. So I guess what should I have said that the range in kilometer or in meter or in centimeter, whatever units you want to, not kilometer square. You are taking us to area measurements. Okay. So I've told you that when you are, I think I'm trying to recall now, I think in the first class, I was saying, okay, it was the first class I was discussing the primary or major classification of survey or in surveying, the geodetic survey and the plane survey. Okay. And I discussed that, okay, plane survey deals with a plane or a flat surface, while the geodetic survey deals with the curvilinear or a curved surface. Now, when a place is a flat surface, the distance will have to be of a small magnitude. And I've told you at what magnitude you can consider a surface to be a flat surface. Okay, who can remind me? I gave an exact magnitude. Who can remind me of what I said about that? At what distance can we say we have a flat surface?
250 meters, sir.
Yes, it's not more than 250 meters. Okay, so that is the range of distance. When your distance is not more than 250 meters. So to continue, for instance, now I want to measure 500 meters. Line A to B now is 500 meters. So, and the area is relatively flat. So to do my distance measurements, I won't that 500-meter switch. I won't do that. What I will do is to what? To do ranging. And that's why ranging comes in. I do ranging. In fact, from point A to B, I may start at I may start at point A, I may not see point B. Or I may be at point B, I may not see point A. Are you getting me? Okay, so if that is the case, I'm not seeing any of the points, no matter if I stand on one of the points, then I have to do the reciprocal arranging. So I create what? Intermediate points, such that the measurements I will be taking, the series of measurements I will take, they are no more than what? 250 meters. So for my ranging, I'll be able to now what? Take my total distance from A to B. I don't know if you get my explanation. Hello? Ademuyiwa Isaka. Are you related to the son of Issachar from the scriptures? The people who understand the time, the season, and the time.
No, sir.
Ademuyiwa Isaka. Do you understand my explanation?
Yes, sir.
Okay. Do you know the season and the time we are in?
Christmas time, sir.
All right. Everybody knows that Christmas is coming, So, all right. So, any other questions? All right. If there's no
Good afternoon,
other
sir.
question, yes. Good afternoon.
Are you going to be getting the previous slides?
I will forward, I'm done with change survey, as I said that I will release the notes as soon as I'm done with change survey. Someone asked me on the platform this afternoon or so. So you get it, later today or tomorrow. Class web, don't forget about your course registration. You guys have to register for lag SVG 217, not the GEY 212. I don't know if you have had discussion with your course advisor and your departmental exam officer. Class web, are you here? Adejare
Yes,
and
sir.
the other class web.
Sir, we're here to speak to our course advisors about it as they've been unavailable.
You want me to stop this lecture? I won't take this class again, no, because we'll just be wasting my time, So we have this class next week, Tuesday, and by that time, I hope we'll have a physical class. But if that's not possible, we'll also do online. But if this matter I just raised is not resolved, I won't show up. What is the name of the other class? I think Adejare is for geology. Am I right?
Yes, sir.
Okay. I'm hearing a lady's voice. Are you the assistant class
No, I'm
rep
the
for
class rep for
geophysics?
geophysics.
Okay, but I've not seen you. I asked you and Adejare to see me. I only saw Adejare. I think he came, is it yesterday or so? Yeah, I think
Sir,
it's
I was
yesterday.
not
Yeah,
aware
Monday.
he was coming. We're supposed to come together and he didn't carry me on board.
Are you not supposed to call him, or he's supposed to call?
He didn't call me or send any message to me concerning coming to your office. He just came himself and told me what you said.
You guys are not secondary school students. You should know how to work hand in hand together, So I'm still expecting the attendance lists. Okay, I've not seen the attendance. And is it the third lecture now or the fourth lecture?
The third one, sir. I'll bring it to you, sir, by tomorrow.
So communicate with Adejare and agreed on the time to come together. Okay. Or are you guys having what's it called now? Controversy before this time that you are not able to communicate well.
No,
So
sir, or not.
So agreed on a time, and the two of you should come and make sure you resolve this course registration issue before next week Tuesday. So have a wonderful evening. So we'll call it a day. We'll see next Tuesday. If all conditions you guys are able to solve this issue. All right then. So